gentlemen, Geo Metro Ninjas, welcome to another exciting, another enthralling, another great day in geometry. I'm super excited to talk to you guys today about the converse of what we've already learned. So if you think back to our proofs unit, our logic and reasoning, we had conditional statements. Conditional statements, of course, were written in if-then form. So if today is Friday, then the weekend is tomorrow. So remember those conditional statements? Well, the way we learned our 5 angle relationships, which were alternate interior, alternate exterior, corresponding, consecutive interior, consecutive exterior, the way we learn that, we can flash back to reality, make sure we don't lose our gravity. But the way we learned it, if you look in the highlighted portion, it says if 2 lines are cut by a transversal, but not just 2 lines, it's specifically in capital letters. It even screamed at us if 2 parallel lines are cut by a transversal, then the following is true. Corresponding angles are congruent. Alternate interior congruent, alternate exterior congruent, same side interior supplementary, which of course means that our sum is 180 degrees. And then consecutive, aka same side exterior, were also supplementary. So we come back to today. Now, we are talking about going the other direction. The way we learn these angle relationships. Hey, lines are parallel. Here's what exists. Let's flip it. Okay. Now we're going to go, hey, if these angle relationships hold, okay, then we have parallel lines. So the converse takes the angles to prove the line. So I kind of drew it out down here. The way we learned our conditional statements, we have if the lines are parallel, then our angle relationships become true. That's the way we learned it. That is the theorem as it is written. Now let's flip it. Now instead of going P to Q, we're going to do the converse, Q to P. Hey, if this angle relationship exists, if my alternate interior angles are congruent, if my same side exterior angles are supplementary, if those things are true, then we can prove our lines are parallel. So it's the same rule, the same location. We're not changing anything except the order of which we know our information. We're looking at the same diagram we've roughly tackled this whole time. Okay, corresponding angles converse. If we look at our diagram, if 4 and 8, if those two are congruent, that's what that means. If those are congruent, then we could say L is parallel to M. Because that congruent relationship only exists within parallel lines. Same is true, alternate interior. If 3 is congruent to 5, 3, 5. Opposite sides of the transversal inside my lines. If those are congruent, then L, line L, is parallel to line M. Remember that double slash means parallel. 1 to 7, alternate exterior, opposite sides of the transversal, outside of my lines. 4 and 5, same side interior. 2 and 7, same side exterior. If those relationships exist, then the lines must be parallel. If they tell us they're parallel, we can say they exist, but we can also use this relationship to help prove our line. So let's take a look at an example. Okay. So they're just going to hit us with one piece at a time. So we want to determine, is L parallel to M based on the information that is given? So we look at this information that is given. We have an angle up here on the right, angle down here on the left. This is my transversal, the line that they both touch, and then this is L and M. So according to the information they've given us, They are on opposite sides of the transversal, outside of the parallel line. So that would make them alternate exterior. Alternate exterior angles are congruent. Does 63 equal 63? Absolutely. So we can say L is parallel to M. Same thing on number 2. We give us hoops now. Okay, remember hoops are a way to show congruence amongst our angles. In this location, we have both of them on the right side of their transversal, both on top of their respective line. This is a corresponding relationship. Okay, in order for parallel lines to exist in corresponding, they must be congruent. Based on those hoops, you're right, there it is. L is parallel to M. Number 3. Again, now we've got our transversal down the middle. Our angles are on the outside. So these are same side exterior. In order for same side exterior angles to make lines that are supplementary, we need to check, does 48 plus 132, is that 180 degrees? So we add 48 to 132. Let's use our calculator to make sure. Sure enough, adds up to be 180 degrees. Two lines that add to be 180 are considered supplementary. So again, L is parallel to M. Number 4, these two angles are congruent. Great, but these are vertical angles. Vertical angles do not help us. They're not one of the 5 that proves things parallel. So unfortunately, this myth is busted. Anybody watch that show when they were younger? Fantastic work. Here we go. Again, L and M. Got a hoop and a hoop. Okay. There's my transversal. We're on opposite sides of the transversal. Inside the line, so that's alternate interior. In order for alternate interior to create parallel lines, they must be congruent. You are absolutely correct, which means that we are good. L is parallel to M. All right, last one, number 6. Okay, there's my transversal, the line that touches 2 or more lines. These are considered same side interior. Same side interior must be supplementary. Let's add 125 and 65. 125 plus 65 gets me to 190. Two angles that add up to be 180 are supplementary, not two angles that add up to 90. So again, no soup for you. We're just throwing in all the 80s and 90s shows right now. I know you guys don't have a clue what's happening, but I bet your substitute is dying. How about shouting out a sub on the old internet video? Okay, so let's put some actual math behind it. Okay, so they want us, given the following information, determine which of lines, if any, are parallel. So we're going to identify the parallel lines, and then we're going to state the converse, meaning alternate interior, alternate exterior, same side interior, same side exterior. Now, to save time, we're going to go every other one, but remember your completed notes are posted on the fall live calendar, so you can go access that to look for the rest of them. So we're just going to go nice and easy, 2 and 4. So we look at 2, we look at 4. A is our transversal. C and D are my lines. We got both on the same side of the transversal. One in, one out. This is C is parallel to D by the corresponding converse. 1 plus 13 is 180. 1, 13, they're both on C. That's my transversal. They touch A and B individually. Same side of the transversal, both outside. So yes, they are parallel. A is parallel to B, same side exterior angles. 14 and 15 is 180. 14, 15. 14 and 15 are both on B, so my transversal is B, and they individually touch C and D. Same side, inside, so C is parallel to D, same side, interior. 4 and 15. 4, 15. They both touch D, opposite the transversal, outside our parallel lines. So, yep, A is parallel to B, alternate exterior angles. Now, this video might be going a little fast for you, but remember, you can always go rewatch this, pause it, slow it, rewind it, fast forward it, make me sound like a chipmunk, whatever you need to do. Hey, this video is available to you, the viewer, whenever you want. Okay, so 9, 13, 9, and 13. Now notice they're on a single transversal and they're on a single line. Okay, so this is not a parallel relationship. This is a linear pair. And linear pairs, much like the vertical angle we saw in the last one, does not prove parallel. Maybe they are, maybe they aren't. But with the information they gave us, we do not know. All right, last one, 6 and 11. 6, 11. They're not on the same transversal. They're not on the same line. These guys are not related. This is no relation. And if they ain't related, they are not parallel. Maybe they are, but there's nothing we got that can prove it. Let's do a couple more. Again, we're going to go every other one just to make sure we save some time. I don't want y'all to sit here and have to watch a video for 40 minutes, and your substitute doesn't want to watch a video for that long. She wants to let you guys get your homework done, and then you're going to be the best students possible for her the rest of the time. So 8 and 13, 8 and 13, their transversal is T. They're between P and Q, which means yes, P is parallel to Q, and that is same side interior. 16 and 20. 16, 20. Both on transversal T, in between Q and R. So we could say Q is parallel to R. I'll put that in the right spot. And that is alternate interior angles. Let's go ahead and slide that down so you're not too confused. Oh, we lost the Q. We brought the Q with us. Q down, Q down. Oh boy, Peter. Oh, well, she's stuck there now. All right. 10, 13. 10, 13. They're both touching Q. So that's my transversal. But the problem is, I know that you know that those two are same side interior. Same side interior angles do not prove congruent unless they're both right angles. So in this case, not parallel. And then 5 and 15. 5 and 15. Let's see. 5, 15. I love it because it jumped a line. Okay, so 5 and 15 are both on transversal T. And then P and Q. So we have P is parallel to Q, alternate exterior angles. Okay, now we get to another transitive property. By this point, I hope you guys get that transitive property. If lines are parallel to another line, if they're both, in this example, they said, hey, P is parallel to Q, Q is parallel to R, it acts just like the transitive property. Since they're both parallel to Q, they must also be parallel to one another. So we could drop the Q and just say P to R. Pretty cool, right? Y'all didn't think you'd be seeing the transitive property again so soon. Okay, so in the example, they said A is parallel to C. Remember, we can show arrowheads to help ourselves. They want us to prove which other lines are parallel. So what we've got, right, is we've got a couple of different lines going on. So I'm going to go ahead and highlight our A and C in light blue so you can see the relationship we already know. Now, we may have to bounce around using different transversals. Maybe we have this transversal on the left, and then we have this transversal on the right. And then, of course, we have line B in play and line D in play. So what we've got to figure out is who else is parallel in this relationship. Okay, so I've got a couple of, so if we use transversal D, or this transversal here on the right, sorry, it doesn't have a letter, then these two lines, so 108 and 62 are same side exterior angles. In order for same side exterior angles to create parallel lines, those two angles must be absolutely supplementary. So 180 plus 108, I got supplementary on the brain, plus 62 is 170. So D is not parallel to C because those two angles are not supplementary. Well, what if we come over here to the other transversal? Okay, again, we're talking about this transversal here. Here are our parallel lines. Again, we've got, it looks like, now this is where it's going to get confusing because there's a couple things happening. If we look at this, they look inside the diagram. And if we're talking about a different angle or a different line, you might be correct. But because we're talking about B and C, we know that these are outside of B and C. So that's where it could get a little confusing on you. But you guys are studs. You guys are rock stars. We're going to make sure that doesn't happen. So 84 plus 96 is 180. So we know that based on that information, B is parallel to C. And then using our transitive property, hey-oh, they're both parallel to C, so we can set them parallel to one another. That's all it is. Remember, this is our transitive. All right, the next thing we're talking about today is how we can use it with algebra. So proving lines with algebra. Now what we're going to do is with the math, we're going to say that they are parallel and we're going to do the math as if they are parallel. So looking at our picture here, we have opposite sides of the transversal inside the lines. So those are alternate interior angles. In order for alternate interior angles to create a congruent relationship, they are going to have to be equal to one another. So we're going to solve this equation because we want to find the value of x that makes that relationship true. So 10x minus 23 is 137. So this isn't any different than the way we learned it. We're just going to assume that what they want to happen is going to happen and make it work. So we're going to add 23 to both sides. So 23 and 137 is 160. Let's write that in there for the audience at home to see. Is 160. And then divide by 10. So x is 16. And remember, to use that, we did alternate interior angles. Again, this is no different than what you guys just did on your quiz. This is no different than the way we learned it with parallel lines in algebra. We're just finding the value of x so that they're parallel instead of them telling us they're parallel from the beginning. But it doesn't change how we do math problems. All right, let's look at number 3. That's an eraser. That won't work. Okay. We've got two angles. They look to be on the same side of our transversal. Remember, the line that intersects 2 or more is a transversal. They are on the same side of the transversal. They are inside line A and B. So they are same side exterior angles. Same side exterior angles must be supplementary, meaning they add up to be 180. So that's what we're going to do. 96 plus 6x minus 30 is 180. Combine like terms on the left side. 6x plus 36 is 180. We're going to subtract 36 from both sides. Show that step so we're not like, what, Coach O, what'd you just do? 6x is 144, and then we divide by 6. X is 24. Okay. Just keep on keeping on. Let's find one that's a little funky. Okay, this guy, he looks funky, but he's not funky. This is our transversal, the line that intersects 2 or more. Then we have 4x minus 18. And we have this box. And you guys are all geniuses, and you know that that box is 90 degrees. Well, these right here, ladies and gentlemen, are corresponding angles. We know corresponding angles in order to be parallel lines. Those angles must be, in fact, you're right, they got to be congruent. So 4x minus 18 is equal to 90. We add 18 to both sides. 4x is 108. And then x is 27. All right, guys, that is it. That's what we're doing. So the biggest takeaway I want you to remember for today is we are using the relationship the same way we learned them. The only difference is we do not necessarily know that the lines are parallel. But if our relationship, the way we learned them, if that relationship holds true, then bang, they are parallel. So guys, I appreciate your attention. Thank you for being such great and amazing kiddos. I hope you have an excellent day, and I will see you next time. Go be great today, weirdos.